Hi, welcome to AhaGuru question types for JEE and NEET. In today's video for this week, we are going to look at electrostatic potential. Particularly, we are going to focus on questions that appear in JEE and NEET based on change in potential energy. Every week in this session, we will be focusing on one very important question type that comes up in JEE and NEET. We will look at previous year question papers, look at the type of questions that come up from one topic, and then analyze how to solve it. For example, this week I am going to focus on electrostatic potential and particularly change in potential energy. Do a lot of questions from change in potential energy comes up? Does it come up in JEE and NEET? Yes, look at this. So if you look at JEE 2025, this question had appeared and the same question had appeared also in NEET in 2005. And I think this question had also appeared once before in JEE Advanced, IIT JEE Advanced, and again once before in JEE Mains as well. So this question has been repeated many times. And what are they asking you? There are two charges Q1 and Q2 kept here. And there is a third charge Q3 that was originally there, and it is basically brought to this point. So when you move this charge from here to there, the question that is asked is, what is the difference in the potential energy? What is the difference in the potential energy? I'll show you how to solve this question. And you can also see these two questions are very similar, right? This appeared in NEET in 2007. This appeared in JEE in 2020. And what are we doing in all of these questions? Basically, a charge is being moved from one point to another, and the question is asking you to find the change in the potential energy. So we are going to learn how to solve each of these questions, and once you do this, any question based on change in potential energy, you will be able to answer, and this kind of question will definitely keep coming up in JEE and NEET, so you're going to find this extremely useful. Every week, I do one such topic where we will basically focus on a particular problem type that keeps recurring in JEE and NEET. And you're going to find this extremely useful for your preparation. So do hit the subscribe button. You can basically like this video and hit the subscribe button, so that way you will never miss any of these episodes where we will be focusing on very important question types that comes up for JEE and NEET. Okay. Right now, I'm going to focus on electrostatic potential questions, particularly focused on change in potential energy. To understand how to solve these questions, we need to first understand what is the change in potential energy. So let us go and look at that a little bit more in detail. Suppose I look at this point and say that the potential at this point has some value, VA. Okay, this point is A. So we will say the potential is VA, maybe 20 volts, maybe 40 volts, maybe 700 volts, maybe minus 200 volts. It can be negative, not a problem, right? So this point has some potential VA. Let us say there is another point B which has potential VB, which may be some other potential, let us say 500 volts or minus 50 volts or something like that. Now suppose I bring a charge and I keep it here. Let's say a charge Q, I bring it and keep it at A. So when charge Q is kept at A, this charge will have a potential energy. How much potential energy? Q into VA. So we can say that the potential energy when the charge is kept at A is Q into VA. It is not the potential energy of the configuration. You can say it is the potential energy of this one single charge. Okay. The configuration potential energy is a much more complicated thing that you will have to take all the combinations of charges. Here we are talking about a single charge that is going to move. The configuration is not going to change, right? So this will be potential VA, that point the potential will be potential VB, right? So only this charge is going to move. When this charge was kept here, the energy, the potential energy of the charge, UA, U stands for potential energy, is Q times the potential at this point. So Q times VA. Now suppose I take this charge and I move it somewhere like that, and it can go along a path like this, right? It can go along this path. It can go along any other path. The path really doesn't matter. Okay, any path you pick, you are going to end up at this point. When the particle is at this point, the potential energy there will be Q times VB. Q times VB. Here it was Q times VA, there it is Q times VB. So what will be the change in the potential energy? Change in the potential energy, we will write it as delta U. Now change is always final minus initial. This was the initial point. That is the final point, right? And change, delta is always final minus initial. Whenever we say delta, remember it is final minus initial. So delta U will be final potential energy minus initial potential energy, UB minus UA. So it will be QVB minus QVA. And if you take the Q out, you can write Q times VB minus VA. What is VB minus VA? Final potential minus initial potential. So this should be called delta V. So Q times delta V. So change in potential energy of a particle when it goes from A to B is charge times the change in potential. Delta V is change in potential. Okay. Now keep that point in mind. That's very useful. Okay. But often we will be talking about potential drop. Potential drop, well, it is the negative of the change in potential, right? Change in potential is final minus initial. Potential drop is initial minus final. So delta V will be VB minus VA. Whereas potential drop is written not delta. It is written as VAB, V subscript AB. So this is VA minus VB, VA minus VB. So here I talked about change in potential energy. The same way we can talk about drop in potential energy. So drop in potential energy of the particle UAB will be minus of the change, because it's obviously initial potential energy minus final potential energy. So we will write it as Q times VAB. Often they will ask you for change, but if they ask you for drop, remember it is initial minus final. So it will be Q times VAB. Whereas when you talk about change in potential energy of the particle, it is Q times delta V. Q times delta V. Okay. Now, so far I hope everything is clear. Now, many times the question will be, how do I find out what is this VA and how do I find out what is that VB? If you know a point charge at a distance r, you know how to calculate the potential. Basically from Coulomb's law and doing some integration, we have a very nice formula for that. So if I have a charge Q sitting here, a point charge Q, at some distance r from it, let us say there is a point P, what will be the potential at P due to this charge? Now if there are many charges, you have to add up the potentials. Potential is not a vector, it's a scalar quantity. So you just have to add them up, right? Now it can be minus or plus, but you have to add up with the proper sign. It is just a number to add, no need to worry about vectors. But what will be the potential at P? V at P will be KQ by R, K times this charge divided by R. So for point charges, finding the potential at any point is very easy. And what if I had one point charge here, another point charge there? Let us say this was Q1 and let us say this was Q2, and let us say you want the potential here. That is quite easy. How do I find out? Suppose I say this is R1 and this is R2, then at this point the potential will be, okay, let's call this point as let us say X. So potential at X will be KQ1 by R1, that is the potential due to Q1 at X, plus KQ2 by R2. Basically the same idea, just that you are using it now for multiple charges. So that's it. Once you know how to calculate the potential due to different point charges at any location, which is a very simple formula, KQ by R, you just have to add up, and it is a scalar addition, not a vector addition. So very simple. And you know that potential energy, right, the change in potential energy is Q times the change in potential. By combining these two, you can easily solve questions based on change in potential energy. Let us now look at JEE questions, the previous year questions from JEE and NEET, and let us see how to use these ideas to solve questions based on change in potential energy. Let us now look at this question that first appeared in the IIT JEE Advanced, and then it was used in NEET in 2005 and again has appeared in JEE Mains in 2025. Okay, now this question is actually quite a simple question. Let us quickly read this. Two charges Q1 and Q2, they are separated by a distance of 30 centimeters. A third charge Q3 that is initially at C, distance of 40 centimeters. We are going to assume that this is y-axis, this is the x-axis, so basically they are perpendicular. So it is basically 40 centimeters up like this. Okay, so initially Q3 is at C, as shown in this figure. It is moved along the circular path. So you're going to move this along this circular path like this, right? So that's how we are going to move. So from C to D. So Q3 is going to move from C to D. Okay, in a circular path of radius 40 centimeters. So if this is 40 centimeters, this will also be 40 centimeters because it's a circular path, right? So that means if this is 40 centimeters, this is 30, this must be how much? 10 centimeters, right? This must be 10 centimeters. Okay, so basically Q3 is moved from here, from C to D. If the difference in potential energy due to the movement of Q3 from C to D is given by Q3 into capital K by 4 pi epsilon naught. Capital K is not Coulomb's constant. Coulomb's constant is small k. This is some other constant. Okay, so Q3 into some K, capital K by 4 pi epsilon naught. Then using this we want to find the value of K, and we have been given 4 options. Okay, the potential energy is changing. Why? Well, the potential energy has a Q1, Q3 component, right? It will have a Q2, Q3 component. It will have a Q1, Q2 component, right? If you take potential energy of a system, you have to take multiple things. But Q1 and Q2, they are not moving. So we can say that the change in the potential energy is because Q3 is going from C to D, and we know the formula when one charge is moving, what is the change in the potential energy. So what will it be? So let me write that the change in the potential energy, generally we write delta U, delta U. It is always final minus initial. This is the initial, that is the final, right? So final energy minus initial energy. But final energy minus initial energy, you can write it as Q times the change in potential, Q3 times delta V. Delta V will be, okay, potential drop is initial minus final. Change in potential will be final minus initial. So Vd minus Vc. So Q3 times Vd minus Vc. So that means we need to find Vd and Vc. Now when we say Vd and Vc, Q3 doesn't contribute to Vd and Vc. Q3 feels the potential, right? Q3 is going to feel that potential, and it's going to basically have a potential energy because of the potential. But who produces the potential? The potential is produced by Q1 and Q2, felt by Q3. If I bring another charge, then all three, Q1, Q2, Q3 will then create the potential at each point that the new charge will feel. But right now Q3 is moving, so Q3 is going to feel the potential produced by Q1 and Q2. So when I say potential at D, suppose I say V at D, you should not take Q3's contribution. You should only take Q1 and Q2's contribution. Q1's contribution to the potential at D, can you find that out? K, small k, Coulomb's constant, times Q1, right? K Q1 by R. What is R? This distance, which is 40 centimeters. So K Q1 by R, 40 centimeters, 40 centimeters. Okay, now we are always going to use SI units. So instead of using centimeters, 40 centimeters, I will write it as 0.4. I will write it as 0.4. Okay, otherwise you'll have to write 40 centimeters. You have to write the unit also. I will avoid that by just writing 0.4. So KQ1 by 0.4, that is the contribution of Q1. What about the contribution of Q2? KQ2 by this distance, which is 10 centimeters. 10 centimeters, 0.1. So plus KQ2 by this distance, which is 10 centimeters, 0.1. Okay, so KQ2 by 0.1. Hopefully this is clear. This is V at D. What about V at C? What about V at C? Well, Q1's contribution, this is still 40 centimeters, no? This distance is 40 centimeters. So we can write KQ1 by 0.4. Notice these two are the same. These two are the same. Okay? Plus K Q2 by what? K Q2 by not this distance, not that distance. Oh, this distance. Because you have to say from the charge to wherever you want the potential. This distance. But what is that distance? Let me basically draw this distance. Right? This distance. How do I find out what is that distance? Let me call this R. This is perpendicular to this. It's not given exactly in the question. They say shown in the figure, it's not very precisely given. So you're going to assume this is 90 degrees. Looks 90 degrees. Well, that's how JEE questions are typically, right? So JEE and NEET questions won't be very precise. JEE Advanced will be a little bit more precise. So there the wordings would have been better, or this would have been marked as 90 degrees. But here, just by looking at it, you say, okay, this is like the x-axis, this is x-axis, y-axis. So you're going to assume this is perpendicular. So then we can use Pythagoras theorem. So what will be the distance R? Root of 40 square plus 30 square. So R will be root of 40 square plus 30 square, which is how much? 1600 plus 900, 2500, root of that will be 50. So this will be 50 centimeters. 50 centimeters is 0.5 meters. So R is 50 centimeters. So if this distance is 50 centimeters, then the contribution due to Q2 at C, V at C, is KQ2 by 50 centimeters. I will write 0.5 because everything we want in SI units, so I'll write 0.5. If you don't write 0.5, if you write 50, you should write centimeters. Don't forget that, okay? So I'm not writing the centimeters, I'm writing this. Okay, now suppose I want VD minus VC, right? That's what I want there, VD minus VC. Well, this minus this, they're the same thing. This minus this will just simply cancel out. So you'll get this minus this. And you see you have KQ2 common. So KQ2 into 1 by 0.1, I'll write it out fully, 1 by 0.1 minus 1 by 0.5. What is 1 by 0.1? 10. What is 1 by 0.5? 2. So 10 minus 2. 10 minus 2 is 8. So this is just simply 8. So you're going to get 8 times KQ2, right? 8 times KQ2. Now what is K? K is 1 by 4 pi epsilon naught. So I can write 8Q2 by 4 pi epsilon naught. What is this? VD minus VC. And we want delta U. Delta U is Q3 times VD minus VC. So Q3 times this. So delta U is Q3 times this, 8Q2 by 4 pi epsilon naught. Now we want to write the answer in this form. Q3 into some K, capital K, by 4 pi epsilon naught. Q3 into K by 4 pi epsilon naught. Notice Q3 by 4 pi epsilon naught is sitting here. So this must be capital K. Just comparing these two, this must be capital K. And the question is, what is capital K? Answer, 8 times Q2. And so that is option D, 8 times Q2. So I hope it's clear. In this, basically we said that the change in the potential energy of the system is going to come because Q3 is moving, and change in the potential energy is basically Q3 times the potential there minus the potential here, final minus initial. So Q3 times VD minus VC. VD we can calculate, VC we can calculate, subtract, get the answer. But you could have also said, wait. VD has a contribution due to Q1 and has a, right? So VC also has a contribution due to Q1. And Q1's contribution is going to be the same because this distance is 40 centimeters, this distance is 40 centimeters. And you can see that, no? Notice, this is the same as this. So why even bother about Q1? So any change that is going to happen because of Q2. So we can say, instead of even writing this whole thing, we could have just directly written KQ2 by 0.1 minus KQ2 by 0.5. KQ2 by 0.1 minus KQ2 by 0.5, and that's exactly what I've written finally, right? Because this cancels out. And so you could have said, I can just ignore the Q1, focus on just the Q2 because that is the one thing where the distance is changing, right? So therefore, KQ2 by 0.1. minus kq2 by 0.5, and so that will give me 8 times kq2, and so from that we can have directly got the answer. That is a little shorter, but the principle is basically this: the fact that you have the same distance means q1's contribution not there, so ultimately it is only q2's contribution, and that's why you get 8 times q2 as the answer. So I hope you have understood how to do this, and this kind of question will be asked again and again. As we will see, the same approach with slightly different variation of questions is what is often asked in JEE as well as NEET. So understanding how to solve such problems is very, very important. Let us now look at this question that appeared in NEET in 2007. Okay, so here we have charges plus q and minus q that are placed at points A and B, which are at a distance 2L apart. A, B, 2L distance apart, right? Plus q and minus q have been placed here. And C is a point that is in between, exactly halfway, midpoint between A and B. So since this is the midpoint of AB, this must be L and this length must be L. Okay? Find the work done in moving a charge plus q along the semicircle CRD. So we know that this is a semicircle. It is not given that B is the center of the semicircle. It's not given, but NEET questions and JEE questions, JEE Mains questions, you cannot expect it to be super precise, right? So if you look at the diagram, they gave the diagram, it looks like B is the center, there's a semicircle with B as the center. Now you have to make such quick assumptions, otherwise you can't solve it, right? So we are going to say B is the center of the semicircle, that's how it looks. So therefore, this is L, this must also be L. This must also be L. And so this plus Q charge, plus capital Q charge is going to move like this, right? And going to go to D. So we're going to move this plus Q along CRD like this. Basically, if Q moves from here to there, why will work be done? Whenever we say work done, we always talk about work done by an external force. Work done by an external force will increase or change the potential energy of the system. So we can say work done, in this case it means external force, not by the electric field. Electric field also can do work, but whenever we say what is the work done, right here the question says find the work done in moving the charge, it means by an external force. And so this is delta U. Delta U. When this charge moves, delta U. What will be delta U? Q times delta V. Q times the final potential minus initial potential. That we already know, right? Delta U is Q times final potential minus initial potential. So that is basically the change in potential energy. Is Q times the change in potential. So Q times V at D minus V at C. So that is basically what is asked. The question is only asking you Q times V at D minus V at C. How will I find out V at D? Now whenever we talk about V at D and V at C, we are talking about plus Q and minus Q, the small q, not capital Q. Why? Because capital Q is the one that is moving. So it is going to feel the potential. It is not going to feel the potential created by itself. It is going to feel the potential created by these two charges, not by itself. So we never count the charge that is feeling the potential itself, right? We should not do that. We should take the potential produced by all other charges. So potential at D, how will I calculate that? V at D. That is easy. You can say V at D due to plus Q and due to minus Q. What will it be due to plus Q? K small q divided by this distance. What is this distance? L, 3L. So divided by 3L. Plus, always write a plus. I know it is minus charge, but then we can put the minus inside. So K into minus Q. So you know that the minus is coming because of the minus Q. K into minus Q divided by this distance, which is how much? L. And then V at C. The potential at C. What will it be? Due to this and then due to that. Due to Q, it will be KQ by how much? By L plus K into minus Q by L. So when you do VD minus VC, notice this will cancel. Does that make sense? Yeah, because as far as minus Q is concerned, this distance is the same as that. So everywhere here, the potential will be the same. Definitely here and there, the potential will be the same. Actually, even if it had traveled like that in some other path, as long as this distance is equal to this distance, the potential contributed by minus Q depends only on the distance. And the distances are the same. So when I subtract, right, VD minus VC, this will go away. So if I say VD minus VC, VD minus VC, this will cancel, this minus this. KQ by 3L minus KQ by L. The sign is important, okay? KQ by 3L, okay, I'll put the L out, minus KQ by L. Can you see? KQ by L, I've taken it common. 1 by 3 minus 1 by 1. What is 1 by 3 minus 1? 1 minus 1 by 3 is 2 by 3. 1 by 3 minus 1 is minus 2 by 3. So I'm going to get minus 2KQ by 3L. That is VD minus VC. No, I don't want that. I want work done. Well, that is capital Q times this. So all I have to do is to multiply this with capital Q. That's it. So if I multiply, okay, everything is written in terms of epsilon naught. So let me also do that. Okay, so if I write minus 2Q, and what is K? K is 1 by 4 pi epsilon naught. So there is a 3L. And for K, I'm going to write 4 pi epsilon naught. All this is so that we can write the answer in terms of epsilon naught. That's all. So if I now cancel the 2 and 4, I'll get a factor 2 here. 2 into 3, 6. So minus Q by 6 pi epsilon naught L. Now that is not the answer. That into capital Q. So if I multiply these two, I'm going to get minus QQ by 6 pi epsilon naught L. Is the minus important? Very important. You can do negative work, you can do positive work. The minus is very important. So is there an answer that matches? 2, 6, 6, 4. So not this, 6, 6. Okay, but this has a plus, that has a minus. This has a minus. So this is wrong. This is the correct answer. Notice, if somebody made a mistake here, okay, and they wrote it as 2 by 3, and you would have ended up with a plus, and that would have been the wrong answer. Instead of getting 4 marks, you will get minus 1. So effectively, you've lost 5 marks. So instead of getting 4, if you get minus 1, what happens? You have lost 5 marks, right? So remember to do it carefully, do it step by step. Now let us think. This actually does not contribute to the change in potential, because here also the potential due to minus Q is the same, there also potential due to minus Q is the same. So the real contribution is only due to this charge, right? There it was 3L distance, here it is L distance. So KQ, okay, final is 1 by 3L, initial is 1 by L. So 1 by 3L minus 1 by L, which is exactly what we would have got. So you could have done it without writing this part, but safer to always write this and realize. Keep in mind that this distance is not going to change. This distance is the same as that distance. So contribution due to minus Q should cancel, and that tells you, yeah, you're on the right path. And so therefore this is the potential difference, final minus initial, and therefore potential difference into Q will give you potential energy difference, which is the work done by the external force, and so therefore this gives us this answer. So I hope you have understood how to solve problems like this. The approach is exactly the same for the previous question as well as this question. Q times delta U is Q times delta V, final potential minus initial potential. The final potential, initial potential will basically be due to multiple charges. You have to basically add up for each point the potentials contributed by each charge, except the one that is moving. The one that is moving doesn't contribute. You find this, then you subtract Find the potential difference. This is delta V. This is delta V. Using delta V, multiply by Q to get delta U. That is the work done by the external forces. Okay, so work done in moving the charge. The answer is minus QQ by 6 pi epsilon naught L. Look at this question that appeared in JEE in 2020. I'm not going to do this question. This question is going to be your homework. Okay, it is exactly the same model of question as the other two. I'll just quickly read this question, tell you the key points and tell you what you can do, but please do it as homework. Okay, so 2 point charges 4Q and minus Q are fixed on the x-axis at x equal to minus d by 2 and x equal to plus d by 2. So this is at x equal to plus d by 2. So this distance is d by 2. This is minus d by 2. So this distance is also d by 2, except it is in this direction. That's all, right? A third point charge small q, third point charge small q, let us put it like this, is taken from here to there, is taken from the origin to this point, which is d, x equal to d. But if x equal to d, this distance must be d, this is d by 2, this must also be d by 2. Because here the point is x equal to d. So this is d comma 0 on the x-axis, so it's d comma 0. So this point is d comma 0. So this charge is taken from here to there. Okay, so now the question is, when this charge is taken from here to there, what will happen to the energy of the charge? So what are they asking? They are asking you to find delta U. And delta U, suppose I call this point, let's call it C and let's call this capital D. Delta U will be Q times delta V, which is potential at D minus potential at C. Potential at D minus potential at C. Okay. Now potential at D will be because of minus Q and because of 4Q, and potential at C will be because of minus Q and because of 4Q. But minus Q's contribution for both these places will be the same. It will cancel out. When you subtract, it will cancel out. And so only 4Q's contribution will matter. So basically you can write the potential at D, you can write the potential at C. You will see that the contribution due to minus Q will cancel. Once you do that, you can find VD minus VC, multiply by Q, you will get what is delta U. Delta U is telling you the change in the potential energy. Change means final minus initial. Now if this is positive, final is more, so that means it's an increase. If this is negative, that means final is less, so that means it is a decrease. So using that you can actually choose the correct option. I'm not going to do this because this is homework for you guys. Very simple. I've given you most of the clue for this. So please do solve this. It will give you confidence to approach every question based on potential energy change. Okay, so please do this yourself. You will realize that these kinds of questions are quite easy. Now, I have showed you one type of problem, right? One kind of question that comes up in JEE as well as NEET and even JEE Advanced, and it has been repeated many times, right? So I've shown you one type of question, but there are many types of questions. And in a session like this, I cannot cover all of them. That's why I strongly recommend that you get the full recorded physics course for standard 12, and you will realize, similarly for standard 11 also I have a physics recorded course where I have done all the concepts required for every chapter, as well as lots and lots of solved examples and practice questions. So if you go through this, you will learn all the different types of questions and all the techniques required to solve these questions. That will make you super thorough, not just for JEE and NEET, but also for your board exams. So please do get this course and subscribe to this channel, so that way every week I will be doing one type of question. I'll go into that in detail. That will really help you for your JEE as well as NEET. Okay, all the best. If you like this video, please hit the subscribe button below, and if you have some comments or if you have doubts in physics or math, please write it in the comment section. I will take one of your questions and make my next video. See you all in the next video soon.